so you don't just click on things. You can have a character that walks around and picks the right tile to stomp. So we're going to build a game like this, like Memory Match in Mario Party. Welcome back to Arcade. I am Super Tommy, and in this series, we're going to look at creating a memory match game, similar to memory games you may have played before with just cards, or seen tutorials for a memory game where you flip over cards to see which to match until the entire board has been matched. But we're going to do it in a little bit of a different way, in a way that's a bit more fun. We're not going to use any cards. We're going to do this memory game more like Super Mario Party's memory match game. So if you've never played Super Mario Party, or just Mario Party, this is Mario Party on the Nintendo 64. And you're given this grid of 9 blocks that Mario has to stomp on to turn them around. And when he does, the items behind on the other side of those tiles, if they match, they'll stay matched, just like a normal match game. And if Mario hits Bowser, he gets dazed and can't move for a little bit. And then there's like this time here. You see that the whole board has to be matched within 45 seconds. And you see there's a bunch of animations. Mario walks around, so you don't just click on things. You can have a character that walks around and picks the right tile to stomp. So we're going to build a game like this, like Memory Match in Mario Party for the Nintendo 64. So we're going to use assets from Kenney. So we're going to take these Animal Pack Redux assets and we're going to show them as things to match. So we're going to do the birds. So we've got a parrot, a penguin, a chicken, and some other bird. Parrot, penguin, chicken, duck. There's the duck here somewhere, this guy. So that's 4. So we have 9, so there's 4 matches. There's going to be 8 tiles that will match each other, 2 at a time. And then we're going to do a bear. A bear is not a bird of any kind, and that'll be our Bowser. So if you land on the bear, or you pick the bear, it'll stop you from moving for about a second or so. Those values can be changed, and we're going to use the Sokoban asset pack, but we're not going to make a Sokoban game. We are going to use these same assets to have a character walk around and allow you to pick a box. We're going to use the silver box, and when you pick it, we're going to change colors to know that you've picked it, and then show you this animation of the thing behind the box. So we're calling it Memory Match. It's basically memory, but a bit more interactive and more game-like. So now our project we have here is from the Phaser 3 parcel template. You can find at github.com/arcade/phaser3-parcel-template. And so this will set you up with a project using NPM. It'll have ESLint and a whole bunch of good things installed for you already. And so we're going to use that here. You can clone this project and follow along if you like. So let's start. We're just going to run this. npm run start just to see what we have. So we just have the basic project running right now. And it should show the phaser logo bouncing around. So that's done. So now we're going to go to localhost 8000. And you have it. Here's the logo bouncing around. So how this starts is this is how the project is structured. So we have this public folder that we made, and it has the textures we're going to use. This is the bear, chicken, duck, parrot, penguin, and our Sokoban tile set. You can download from the Kenney links that I just showed. So we've put these here ahead of time. You'll have to download each pack separately and pick out your images. And so now we have this scenes folder with the Hello World scene that is doing this that you see. And so we don't actually need the Hello World scene, so let's just delete it. We're gonna make a preloader scene and then a game scene that has our game. So let's just delete this. Delete. Nope, that was rename. Delete. Okay, so we're gonna make a new file here. We're gonna call it preloader.js. Import phaser from phaser. And then we're going to export default class preloader extends phaser dot scene. So we're just making a scene. If you've seen any other videos on Arcade, when we make these phaser tutorials, we usually make a new scene, at least for our game. And we're going to give it a key here, preloader. So here we're going to preload all the textures that we just showed you. And then on create, that means everything has been preloaded. We're going to go to the game scene. So now let's make it the game scene. We'll put this in this scenes folder, game.js. Same thing, we're going to import phaser from phaser, and then export default class game extends scene, extends phaser.scene. And then just like before, game. And then we won't need to preload anything in this scene since we'll have done all our preloading ahead of time. So let's put that in create, and we'll do a console.log game scene. So we'll see that it has changed scenes after we do the preloading. So first, let's just preload this .load. We're going to do a sprite sheet. We're going to call it Sokoban. These are the Sokoban tile sheet. And it is at textures. And now let's see what the name of this file is. Textures. So it's in public textures. The VS Code has collapsed into one line because there's only one folder in the public folder. Sokoban tilesheet.png. So let's just copy that. .png. Now we need to give it a frame width at the very least, which is in our case 64. So that means the tile set is 64. Each frame is 64 by 64. So we have that. Now in create this .scene.start. Now we're going to start game. So this key here relates to this key that we pass into the super inside this constructor for our game scene. So now let's go back to main. So this no longer exists. You see there's a red line here. So we're going to import preloader from scenes preloader. Then we're going to import game from scenes game. Now we've also changed the width from 800, that's default, to 700 so that it fits better with less space here. First one, preloader, second one, game. So in Phaser, the first scene that you put into this array will be the one that is automatically run, and the rest of them will not be automatically run. And so we have this here. Good. Save. It's going to auto rebuild, and it should reload. We got nothing. Let's do an inspect. And we have this log that says game scene as we expected, since that's what we put here in game. Okay. So now let's add a sprite that'll represent our player. This.add.sprite. So let's just put them in the middle. So we're going to use object destructuring here. This is a modern JavaScript feature. So this.scale. So the scale manager has a width and a height property, and we're going to just destruct it into the width and the height variables here. So what we can do is width times half to put them in the middle of the screen, and then height times half for the center, maybe center and middle of the screen, and we're using this Sokoban texture key. Now frame, so since it is a sprite sheet, there is many different sprites here, let's say, or different frames here. And they're all 64 by 64, and so there's about 13 across this row. You can count them, but there's 13. We want this one, so it'll be 13 times 4, which I believe is 52. And then it'll be 0 based. So this guy will in fact be 52, I think. Let's try it. 52. Let's see it. And here he is. Now let's say I don't do this frame, right? It'll just show the entire sprite sheet. Or nothing. Just do it. Oh, I did not do it. Oh, because I loaded it as a sprite sheet. Or maybe it picked 0 is what happened, right? Let's see. Let's see. Is 0 blank? 0 is blank. So this is 0. Let's do 1. Default to 0. So 1 would be just this, this crate. So there we go. 52 is the one we want. So there's our guy. And in this spreadsheet, we have animations here actually. So these 3 frames is his walk down, and like this would be like idle facing down, and then there's walk down. This is the facing up and then walk up. And then these are, if you can tell, there's an outline here. We're gonna use the unoutlined versions, which is this row and this row are the unoutlined versions. So we're going to create animations after we preload the spreadsheet so that we can use it in our game scenes. So let's go here in our preloader. After preload inside create, we'll just make all our animations here. This dot anims dot create, and then let's see. Oops, not command. Control space. And so key is going to, oh no, this is the key of the animation. So let's call this down. Let's call this down idle. Frames, and we don't, so we know, okay, we're going to use this dot anims dot generate frame numbers to help us in other animations with multiple frames, but we know this animation has only 1 frame, so we're just going to, in this frames array, put in the actual, so key, and this is Sokoban, this is the key of the texture, then there's a frame, and then the frame is going to be 52. So this is the idle one. That's the one we already see here. So now that he's standing idle. So that's down idle, facing down. Now let's do create. Key, and we're going to do down walk. And okay, so frames. This dot anims dot generate frame numbers. Let me move myself. Generate frame numbers. It also wants a key, which is the same Sokoban key. And then it's going to want a start to which frame it should start at, which is 52. And then there is 2 more frames. And then there's end. So 52, 53, 54. So 54. Okay. Let's go back to game here. And so now if we just omit this 52, and instead we do play, call it down idle, right? So nothing should change. Look exactly the same. It's not moving. Still good. Now we're going to do down, let's do down walk. You should see that he's going to animate up. Yes, we need to add looping. So you saw one animation basically. So frame rate, let's say 10, and then repeat is -1 so that it loops forever. So it'll loop as long as we're in the walk animation. And there he goes. Doot, 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 doot. Okay. Now let's do it for the up, left, and down animations. So we can mostly take this, copy this, right? So this is going to be, let's say up, and this will be up walk. And let's look at what up would look like. So up is here, so this is 52, 53, 54, so 55, 56, and 57, so 55, 57. So the idle is 55, and then the up walk is 55, 57. Now let's do up walk. There he is. Okay, so now let's go ahead and do left. So this is left idle, left walk. And so left is this one. So let's count. 1, 2, 3, 4, 5, 6. So 6 times 13. I'm just going to use calculator. 78. So 78. So 78, 79, 80. So 81 to 83. I think we'll see. Left idle 81. So 81 to 83. 83. So let's try left walk. Good. And lastly, we'll do right. So right idle, right walk. And let's see, so this was 81 here. So 80, 79, 78. 78. So 78 to 80. That's right. Let's see it. There we go, right walk. Okay, good. So now let's store our created sprite, that's our player sprite, in a class property. So now the Phaser 3 parcel template comes with the class properties plugin for Babel, so that you can do this out of the box. So you store or you declare a class property in the field in the class field area here. We're going to use some JS docs to type this. It's going to be a phaser.gameObjects.sprite. Right, and then we're going to do this dot player. So now let's go to update. So we want to move our player when we use the arrow keys. And to do that, we're going to use Phaser's cursor keys. So in the init, let's go to init here. We're going to create another class property called cursors, and it's going to be of type phaser.input types.input.keyboard.cursor keys. Okay. And then we can do this dot cursors equals this dot input dot keyboard input dot keyboard dot create cursor keys. This will give us the space key and the arrow keys. So here, let's make a speed variable and say this guy can move at 200. Oh, yes. Okay, let's make him a physics sprite instead. We will have things to collide with. So this right now is just a normal sprite. But let's make him a physics sprite, and we're already using arcade physics here. We're going to want no gravity. We're going to walk in this area without, it's not side scrolling, it's more top down or like a little bit 3/4 view, let's say. So we're going to turn off gravity, we're going to have speed here, and instead of this dot add, it'll be this dot physics dot add dot sprite, and then instead of that, it'll be physics dot arcade dot sprite. We're using arcade physics for this. So the speed is going to determine the velocity it's going to move at. Okay, so if this dot cursors dot left dot is down, so if we are pressing the left arrow key, this dot player dot set velocity x, so we're going to go at minus speed, so that's left, and this dot player dot play, which is I think it was left walk, and we're going to want the second parameter ignore if playing to be true. And let's change this here to be down idle. I think what we'll see is when we press left, he's going to walk left and then not stop. Yeah, since we don't stop him here. So else if, let's just do the right, if cursors dot right dot is down. So this dot player dot set velocity x, just speed this time. So we're going positive 200, that's to the right. Player dot play, and it'll be right walk, and then true for that. So if it's not pressing left or right, now it could be pressing up and down, of course, but we're just going to say this set velocity x 0. Let's try here. Right. So when we're not going, this dot player dot play, and so we're going to want to know which idle to use because we have a left idle and a right idle. So what we're going to do, let's get the key here. So this dot player dot anims dot current animation, current anim dot key, and let's see, how should we do this? We'll do multiple lines. So we're going to get the parts. So key.split. So since we have our keys created this way, right, whereas go here, see them all. we have direction and then the state. Direction, state, direction, state, separated by a dash. Because we did that, we can split it by the dash, and then we know that index 0 is direction, and then index 1 is state. So what we want, in this case, so direction is going to be parts 0. So that'll be left or right, depending on which one we last pressed on. And then when we want to play direction dash idle. So that's direction dash state. And this is string interpolation. We're just basically combining our variable direction, the value of it, with dash idle. And here that is. So now let's see. And stop. Stop. Good. Now let's do this for, let's see. Okay, let's do this. So else if this dot cursors dot up dot is down. So this dot player dot set velocity y, up is going to be minus speed on the y, and then this dot player dot play, it'll be up walk, and this will also be true. Now the main difference here that we have to do, let me see if I can just show you. So we go up, but doesn't stop, right? So there's no stopping, even though we unpressed it because of this. Now, let's just do this for now. That might work okay. Stop and left and right, okay? Or rather, and right and left. So now if, this is the last one, cursors dot down dot is down. So now we're going to go down. This dot player dot set velocity y is speed, and then this dot player dot play. We're going to, of course, doing down walk and true. Okay, so up, down, right, left, and he's stopping. Right, good. Now the diagonal, we could stop if we don't want to do diagonal walk, and maybe we don't. It looks kind of strange. So let's very quickly stop that. Let's get rid of. Do we need to get rid of that? Let's get rid of that. I don't think we need that. Instead, what we're going to do is if you're moving up, you can't be moving left or right, up or down. So what we're going to do instead here is 0 and speed on velocity. So both components of the velocity vector. 0. And then we'll do the same thing for when you're moving right or left. You cannot then be moving up or down. And delete. And now let's see. Yep, there is no more diagonal movement. Good. That looks better, at least for the way. Oh, now it doesn't stop. So, oh no, I didn't need this here. If neither up, down, left, or right is pressed, of course, then you set velocity to 0 for both x and y. Right, and no diagonal. Okay, so this is the very beginning. We've got about 23 minutes here. So in the next part, we are going to create the actual crates that our character will be able to pick to show you what is behind them.